All right, so question number 10A says the transformation M, which is 0p q0, maps the point R onto R prime as shown in the diagram below. All right. Now, for those of you who are very familiar with transformation, R is going to become R prime. If you're very familiar, you'll see that this is an anti-clockwise rotation of 90 degrees. If you're familiar with transformation, you'll see that this is an anti-clockwise rotation of 90 degrees. All right. Now, what we're asked to do is to determine the value of P and Q. Now, for a transformation, what you do is you multiply the transformation, the matrix representing the transformation, by the point. The point is R, and R is the point 2 minus 5, 2 minus 5. So it's 2 minus 5. You multiply it by R, and it becomes R prime, which is 5, 2. So this is R, and this is R prime. So when you're applying the transformation, the matrix representing a transformation to a point, what you do is you multiply. So let's multiply. This is 0 times 2 is 0. P times minus 5 is minus P. All right. So that's the row times the column. Now the bottom row times the column. Q times 2 is 2Q. And then 0 times 5 is 0. And this is equal to 5. All right, let's just double check. 0 times that. Oh, this should be minus 5p. All right, 0 times 2 is 0. 5 times minus p times minus 5 is minus 5p. All right, I knew something was wrong. Q times 2 is 2Q. 0 times 5 is 0, and this is equal to 2. So therefore, minus 5 times p is equal to 5. Divide both sides by minus 5. And p is equal to minus 1. Um, 2 times q is equal to 2. So q is equal to 1. This says describe fully the transformation M. So you should be able to do that because you received a diagram of the transformation. So everybody should be able to see that R is mapped toward R prime by R 0 plus 90, which is an anti-clockwise rotation of 90 degrees about the origin. Moving down. All right. All right, so now we're at the B part of the question, and we're told that PQRS is a parallelogram in which PQ is the vector U, PS is the vector V, and M is on QS such that the ratio of QM to MS is 1 to 2. Now, when you divide something in a ratio 1 to 2, you're dividing it into what? 1 plus 2. You're dividing it into what? Into 3 parts. So if I divide something in the ratio 1 to 2, I'm dividing it into a total of 3 parts. So QM is 1 part out of the 3, and MS is 2 parts out of the 3. We're to write in terms of M, U, and V an expression for QS. So let's get QS. Remember, I would have told you whenever you're asked to find a vector, most times you're going to use the triangle law of vectors. So QS would be equal to QP plus PS. Start at Q, end at X, the next letter is in the middle. All right, now since PQ is U, QP would be minus U. So this would be minus U plus PS, which is V. I generally like to put the positive first, so this is V minus U. So QS is V minus U. We're asked to find QM. Guys, remember we said that that QS is divided into 3 parts. QM is 1 part of the 3, and MS is 2 parts of the 3. So QM is actually 1/3 of QS. QM is 1/3, this is 1/3, and this is 2/3. QM is 1/3 of QS. That means that QM is 1/3 of QS, which is V minus U. Stay with me. Next, we're asked to show that MR is U is 1/3 of U plus 2V. So let's get MR. MR, which is from here to here, we're to show that MR is something. Now, using triangular vectors, I'm going to say that MR is MS plus SR. MR is MS plus SR. Remember, if over here is U, over here is also U. So let's do this. MR is MS plus SR. Now, MS is 2/3 of QS, and SR is U. So this is 2/3 of V minus U plus U over 1. The LCM is 3. Remember, when we're finished with it, it's supposed to be 1/3 U plus 2V. 3 into 3 is 1. 1 times 2 is 2. So this is 2V minus U plus 1 into 3 is 3. 3 times U is 3U. Distributive law, 2V minus 2U plus 3U over 3. This is 2V, 2U, good. So this is 2V plus U over 3. We could put the U first. So it's U plus 2V over 3, same thing. So MR is 1/3 of u plus 2v. That's what we're asked to show, and we did it. Remember, dividing by 3 is the same as saying multiplying by 1/3. Lastly, we're told that T is the midpoint of PQ, and we're to prove that R, M, and T are collinear. So T is the middle. We're told that T is the middle of we're told that T is the middle of PU. So that's this point here is T. If it's in the middle, and we're asked to show that M, T, and R are collinear. T, M, and R are collinear. That means they're in a straight line. Remember, two vectors are in a straight line when they are parallel and they share a common point. Two vectors are parallel if they have the same base vector. So what I'm going to say that, so I found MR already. I now need to find TM. Ladies, gentlemen, TM is TQ plus QM. TM is TQ plus QM. So remember, T is in the middle of PQ. So TQ is a half of PQ. And remember that QM is 1/3 of QS. So a half, this is a half of U plus 1/3 of V minus U. The LCM here is 6. And we're trying to prove that T, M, and R are collinear. 2 into 6 is 3. 3 times U is 3U. 3 into 6 is 2. 2 into V minus U, distributive law. 3U plus 2V minus 2U over 6. So 3U minus 2U is U plus 2V over 6. So TM is 1/6 of U plus 2V. And we know that MR is 1/3 of U plus 2V. All right. So if you look carefully, you see that the section U plus 2V is the same for both vectors. That means that the two vectors have the same base vectors. And when two vectors have the same base vectors, the two vectors are parallel. So TM and MR are parallel, and M is common. Therefore, T, M, and R are collinear. And the word collinear here means they're in the same straight line. They are collinear, which means that they are in the same straight line.